Hello students, let us try to understand the substitution reaction of alkanes students. Okay, what is the meaning of substitution reaction students? Suppose we are having the hydrogen in the alkane. Okay, there are 4 hydrogen in the methane, and what we are going to do, we are substituting with the chlorine. So what is one chlorine substitute the hydrogen? Okay, so by replacing one hydrogen, the chlorine is getting added there. Okay, so this is what is the product is being formed, and here what will compound will there is Cl, and what is that is HCl is here, right? So this is chloromethane, right student? This is the chloromethane. So what we are able to understand, student, in the substitution reaction we are replacing one hydrogen by another elements. That is what is substitution reaction. Let us try to understand with what are given in the NCERT book. One or more hydrogen atom of alkanes can be replaced by halogens. So here see, one hydrogen atom is, or the more hydrogen atom is getting replaced by the halogen, or that is nitro group and sulfonic acid group. Okay, any group can replace this, whether halogen, nitro group or the sulfonic acid group. Okay, what is the halogenation, students? If you see, halogenation takes place either at the higher temperature 573 to 773 Kelvin, or in the presence of diffused sunlight or ultraviolet light. Okay, diffused sunlight or ultraviolet light. Lower alkanes do not undergo nitration sulfonation reaction. Okay, these reaction in which hydrogen atoms of alkane are substituted are known as substitution reaction. The reaction in which they are saying hydrogen atom of alkane is substituted are known as substitution reaction. As examples, chlorination of methane is given below. So what they are happening, students, here there is carbon is having 4 hydrogen and treating with the chlorine in the presence of sunlight. So one hydrogen is replaced by the halogen. Okay, so chloromethane is formed. That is also possible in the chloromethane. You can treat again with the chlorine, students. So what you will find, that is dichloromethane. You will find, student, that is again this is HCl. If dichloromethane is there, you can treat with the chlorine. This is trichloromethane will form. If you are having that is CHCl3, so that is CCl4 will form, carbon tetrachloride. So every time one hydrogen atom is getting replaced by the halogen atom, so that this is what is known as substitution reaction, student. Okay, up now here you see the same way if you are taking the ethane. Okay, so here also you can treat with the chlorine in the presence of sunlight. So one hydrogen atom is getting replaced and it is giving, that is, this one is chloroethane and HCl. Okay, what they are saying, it is found that the rate of reaction of alkanes with halogen is in the order F2 is faster than Cl2, Br2 and I2. This is the order of the rate of reaction. Okay, that you keep in mind. Rate of replacement of hydrogen of alkanes is what is there, student? 3 degree, 2 degree, 1 degree. This is the rate of order. So 3 degree, alkanes give faster halogenation, then 2 degree, then 1 degree. Okay, fluorination is too valent to be the control. Okay, fluorination, if you are treating with the fluorine, it is too violent to be controlled. Okay, iodination is very slow and the reversible reaction. So iodination, they are saying this is the very slow, students. Iodination is very slow, and they are saying, what they are saying in the case of iodination, that it will give the reversible reaction, you see. Okay, it can be carried out in the presence of oxidizing agent like HiO3 and HNO3. Okay, now you see that is methane is there, it is getting treated with the I2, so it is giving CH3I plus Hi. Okay, and if you are treating that is HiO3, so what is happening, student, it get react with the Hi, whatever the form, and it is producing I2 and 3H2O. So this is what the small amount of you have to take, either HiO3 or HNO3, that is oxidizing agent. Halogenation is supposed to proceed via free radical chain mechanism involving 3 steps, namely initiation step, then propagation step, and lastly chain termination step, students. So this is the free radical mechanism, 3 step involving. So let us see, student, mechanism. So first step is what is there, student? Initiation. The reaction is initiated by homolysis of chlorine molecules in the presence of light or heat. Okay, the reaction is initiated by homolysis of chlorine molecule in the presence of light or heat. The Cl-Cl bond is weaker than the Cc and CH bond and hence is established to break. So they are saying that is Cl-Cl bond is what they are saying weaker than Cc bond, okay, and CH bond. So that if your sunlight is falling, so it will give the chlorine free radical, student, like that. So one electron is going on it and another electron is going on it of the single bond and it is forming chlorine free radical. Now we are going for the chain propagation where the chain will be longer. So chlorine free radical attack the methane molecules and takes the reaction in the forward direction by breaking the CH bond to generate the methyl free radical with the formation of HCl. So here is methane is there, students, and this methane is treated with the chlorine free radical. So it will give the here is it will give the methyl free radical and HCl will released. The methyl radical thus often attack the second molecule of chlorine to form CH3Cl with the liberation of another chlorine free radical by homolysis of chlorine molecule. So here what the methyl free radical formed, student, that react with the another chlorine free radical and it form the product CH3Cl and chlorine free radical again form. The chlorine and methyl free radical generated above repeated step A and B respectively and thereby set up a chain of reactions. The propagation step and A, B are those which directly give principal product, but many other propagation steps are also possible. So that is what is the A and B are the principal step, and the B, in the B step the product itself is getting formed. Now you see, students, here what is happening, and many occurs. Two such steps given below explain how more highly halogenated product are formed. So you see, students, what is CH3Cl is getting react with the Cl chloride free radical, it will give the CH2 Cl free radical NaCl. This CH2 Cl free radical will react with chlorine, it will give that is CH2Cl2 plus Cl free radical. Now these are the free radical are getting continuously forming in the step number 2. Now we are talking about the termination. The reaction stops after some time due to the consumption of reactants and or due to the following side reactions. The reaction stop after the some time due to consumption of reactants, okay, and due to the following sides reaction. The possible chain termination, how two chlorine free radical combine to form Cl2, two methyl free radical combine to form that is ethane, and one chlorine methyl free radical and one chlorine combine to form the chloromethane. So what the point you are getting in the third step, student, terminal, when two free radical combine the chain get terminated. Though in the C, CH3Cl, the one of the products is formed, but free radical are consumed and the chain terminated. The above mechanism help us to understand the reason for the formation of ethane as the byproduct during the chlorination of the methane. Okay, so once more I am going to explain that is the mechanism of the halogenation, student. Mechanism of halogenation. Of alkanes. So mechanism of halogenation of alkane. This is the reaction, student. Here is hydrogen, here is hydrogen, this is hydrogen, this is hydrogen, and here is chlorine is getting treated. So this is getting replaced and it is forming what, student? This product is forming hydrogen, chlorine, and here is HCl. So this is the what is, student, chloromethane. Okay, chloromethane. This is what is the product. Up now let us see the mechanism, student. This is the mechanism. So dear students, if you talk about the mechanism, how can you be able to understand the mechanism, students? Okay, so mechanism is involving 3 steps, students, 3 steps. So let us see the step number 1. What is that? Chain initiation, student. Chain initiation. If you in the chain initiation, that is Cl bond is weak bond, student, due to the repulsion, lone pair repulsion. So what will happen in the bond? What is there, student? This bond is formed by the 2 electron. So that is 1 electron will be broken out in the presence of sunlight, student. Sunlight. So it is getting broken and it will give that is Cl plus Cl, and that is what is student, that is known as chlorine free radical. This is what is known as chlorine free radical, students. अब now that is step number 2. If you talk about step number 2, student, so step number 2 involved that is the chain propagation. This is what is known as step number 2, chain propagation. Chain propagation. And in the chain propagation, two things are happening here, you see, A and B. So firstly we are having that is, here is methane we are having. No, here methane are there. And this methane we are having, what we are going to treat with the chlorine free radical. So this bond is getting broken, this free electron on the carbon, this free electron is going to combine here. So what is there, it is giving that is CH3 free radical plus that is, it will give that is HCl. Okay, now this CH3 free radical, student, CH3 free radical again attack on the chlorine. So what will happen, student, these two chlorine and CH3 combined to give product CH3Cl. This is what is the product, student, product, plus again chlorine free radical will form. These two steps are continuously taking place, student. Last step is there, student, last step number 3. This is what is known as chain termination. Chain termination step. Okay. So what will happen, student, in the chain termination, two free radical combine to give the product. Here you see, student, suppose we are combining that is one Cl free radical, another Cl free radical, it will give that is Cl2, student. Another condition is what is possible, student, in the second case, CH3 free radical plus CH3 free radical combined to give the ethane, student. No, this is ethane. Third condition is also what is possible, CH3 free radical combined with the Cl free radical, it will give that is CH3Cl. So this is what is our mechanism, and in which that is major product is this, student, chloroethane. So thank you so much for watching, friend. I hope this video is helpful. If you find this video helpful, please do like and subscribe the channel, student. Thank you so much for watching.